my Hantek DSO2D15, and it's a digital storage oscilloscope that I didn't get that long ago, and I was very excited when I got this, and I still love it. But while I was doing an introduction to transistors video, I decided to build a circuit to demonstrate amplification in a transistor, and I was injecting a signal because this also has an AWG, which is an arbitrary waveform generator. Us old folks would call it a signal generator. I think they call it an arbitrary waveform generator. Try and say that after a few beers. Because the waveforms that it generates can be various shapes. The old analog type of signal generator would normally just generate a sine wave. Whilst demonstrating the transistor amplification factor by injecting a signal into the actual circuit, I managed to introduce a voltage to the signal generator, or the AWG, on this that it didn't like, and suddenly I no longer had an AWG. I could have just gone and bought myself an AWG standalone and just ignored the fact that this was no longer doing what it was supposed to, but it just kind of irked me, the fact that it was no longer working. And if something's broken, if I can fix it, I will try and fix it. So what I'm going to do today is I'm going to get into the back of this thing and I'm going to try and fix it. Just before the video starts, a quick note. Electricity is very dangerous, and this is not a how-to video, nor am I advocating that you follow along. You do so at your own risk. Let's go. Now, as is evident here, I've now got this hooked up to the generator, and we do have a DC offset voltage being generated, but nothing else. Now, I was watching some teardown videos, care of Kerry Wong, and I will put in the description below this video a link to his channel, because he does some great teardown videos on these Hantek scopes. And that's what made me kind of think maybe I'll be able to fix this, because in the teardown, the signal generator is basically sending its output to an operational amplifier. So what I have done is I have gone and I have ordered the part. Now, this is the second time I ordered the part. The first time I did it through AliExpress, the parts didn't arrive and I was a bit slow in cancelling. It was only $5 or whatever, but this time they have come in. They are little surface mount chips, and I've got lots of them, but I'm going to hopefully only need one, I'm hoping. So I will tear the back off this and see if I can detect the signal coming into the actual chip. And if that's the case, even if it isn't the case, I'm probably still going to replace it anyway and just suck it and see. But we'll do the teardown, and I should be able to find that chip quite easily. There's not that much on the board when it comes to the AWG, and hopefully we will have that signal generator / AWG back in operation. Fingers crossed. Now there's an RF shield on the back of this thing that needs to come off as well. Then we can start the fun part of trying to get that waveform generator operational amplifier chip off the board. So that's off, and this is the back of our scope. So I will move the camera and we can have a quick squeeze, and I can show you what I believe is the chip that is the one that needs to come out. So it would appear that if I'm looking at 2 and 3 as inputs and 6 as an output, that is where I should be able to see signals. So I'm assuming there'll be nothing at 6 and something at 2 and 3. Fingers crossed. So we've taken the tip off our probe here so we can get a finer point, and you can see in the background there the actual scope trace, and I am hoping that I've done a little bit of an earth extender here. I'm hoping that when I hit pin number 2 and pin number 3 that we get some signal, because that will be an indication that all is good. And I don't know if you can see it there, but there's definitely some signal happening. I might just try to go down in volts per division. And there is some signal there. And let's go to 3. And signal there as well. So that would indicate that our arbitrary waveform generator is working. And so I am going to replace that chip and see if we can get it back online. I'm hoping you can see that we've managed to get one side of the chip up. So we are well on the way to getting this thing out and leaving the pads there as well for a change. And we have got it out. We just need to clean the pads up. It appears there are no schematics available, but on the EEV blog, there is a reverse engineered schematic, which, you know, would have taken, I don't know how people do this. People must be just hugely intelligent to be able to do this. Much more intelligent than I am. I've looked at this schematic, and this is the operational amplifier. I managed to find all of these resistors on the board and measured those all. They're all okay. I've checked a lot of these inductors and whatnot. None of them are open circuit, but we have a dead R139, which is not on any of the resistors on any of the boards that I can find. What did happen though is when I've measured across the R139, I get 6.14 mega ohms, a massive, almost open circuit resistor. And what happened was this resistor is going from pin 6 to pin 2. Now, when I measure from pin 6 to pin 2, I get exactly the same resistance as this resistor. And when I measure to this side of the resistor and pin 2, I've got a short circuit. And when I measure from this side to pin 6, I've got a short circuit. So that would tell me, as far as I can tell, that that's the resistor we're dealing with. And it has a value of 750 ohms. So what I'm going to do is I'm going to try and just get a normal through-hole component onto those pads. There's no components near it so that it can snag on or cause any issues with. So lead lengths are obviously longer than they should be, but I think we'll get away with doing it that way. And I will go to Jaycar tomorrow and pick up that resistor and see if we can bodgy this back together. Well, it's the weekend again, and we have gone to Jaycar, and we couldn't get surface mount components, obviously. We have the resistor, which we think is the correct value, and it is going to go in here. I've done an absolute bodge job of getting this surface mount thing in. I hope I haven't destroyed it with too much heat, but I have about 100 more of them to put in, so if we have to remove it and try again, we will. But we have found that this resistor here, which has now been removed, was 750 ohms, and so that needs to go in. So that's the next thing that will be happening. And we're just going to use a normal through-hole component, get the leads reasonably short. It's going to be pretty bodgy, but just to see if that works. Now, I could tell you a little fib and say that we've got our wave generator working just the way we want and everything's good. Noise, exponential, ramp, sawtooth, square, and our sine wave. But you can see down here that that's supposed to be 7 volts peak to peak. And on channel 2, which is the green channel, we've got our division set to 1 volt. So a 7 volt amplitude, we're only getting 1 volt peak to peak. So I would think that that's most likely due to, and I've tried a couple of these op amps, they're probably rubbish. And the more times I rip and tear at this board, surface mount components, etc., without correct surface mount component reworking equipment, the more chance there is that I just completely tank the scope. I would say that this is a pretty much a failure. I always like to have a crack at fixing something, but I'd also like to know when it's time to call it quits. So what I'm going to do is I'm just going to buy myself an arbitrary waveform generator as a separate piece of equipment, and it will sit off to the side, and that will save me from any more ripping and tearing at this board. And let's face it, I've got other ham stuff I want to get onto, other sexier stuff that's going to be a lot more exciting. So that's it for now. Look, valiant attempt. I'm sure in the comment section below people are going to give me some great advice. I certainly do want to do more surface mount stuff, but I really need to get the correct equipment, get some reworking stuff, a magnifier, etc., etc. It's very hard for me to see, even with the headset that I have, the what I call the blind goggles that I stick on my head when I'm working on kits and whatnot. That is probably still not enough to work surface mount for me. I think I really do need a digital microscope so I can really see what's going on. So that is it. So it doesn't always have a happy ending, unfortunately. That's the end of this episode. Sorry that it didn't come to a happy ending and a scope that's completely 100% working. But that's how the cookie crumbles sometimes. Sometimes stuff works and sometimes it doesn't. At any rate, like I said, it's a chance to buy myself a new piece of test equipment, which always makes me happy. And I'm going to now head off into some other projects that I have on the fly. And so stick around for that episode that's coming up, because the next episode will be more ham related. So please don't unsubscribe just because I'm hopeless at electronics repair. 7-3. And I'll see you in the next episode of The Art of Engineering.